exciting talk about CDI
Oh.
and logging. He's going to inject live. All yours.
All right. Hi, everybody. As you know, my name is Raymond Auge from this slide. I'm a senior architect at Liferay. And today I'm going to talk, I'm also co-chair of the EEG at OSGi. Today I'm going to talk about CDI and OSGi, because for quite a few years now, OSGi has had a desire to kind of integrate with the CDI technology from JavaEE. So first thing I want to do is ask, who's a CDI expert here? Awesome. I can lie my face off, and nobody will know any better. So that's great. So the next thing I want to say is that since this is ongoing spec work, everything I'm going to show you is subject to change at any time, because, you know, this is my safe harbor statement to say that we're trying really hard, but it probably won't look like this, or, you know. Okay, so on to the nitty-gritty. So we have some requirements that we want to fulfill in kind of making this, you know, working on this specification. CDI is a very well used and very deeply entrenched technology when it comes to JavaEE, and we want to make sure that we respect the spirit of the design of CDI, and so we have some key goals. The first one is to develop a simple and intuitive model for existing CDI developers. So basically, first thing, we don't want to scare the pants off CDI developers when they look at what we propose them to do. So that's the first challenge. The second challenge is we really want to simplify some of the OSGi, I see challenges here, but really what I'm meaning is concepts, so that they can kind of assimilate them in you know, as a fluidly and with as little resistance as possible. The third major one, as I expressed at the beginning, is that we want to take advantage of CDI's design as much as possible and not go outside of what an expert CDI developer would do to build extensions on top of CDI. And this basically will allow us to be much more compatible with the already large ecosystem of extensions that CDI provides, which is, you know, ranges widely from transaction management, integration with JAX-RS, effectively all the JavaEE technologies. And lastly, to enable the simplest migration path for existing applications. And all of these we've codenamed dist. That was a joke, by the way. So on the OSGi side, we also have some key goals, right? We want to make sure that we deliver enough value to a developer that they can take advantage of what we have on in OSGi and make use of it inside of a CDI application. So the main one is to be able to provide services. And that, you know, goes both ways. It's provide and consume services, really. And the second one is we really want to make sure that we retain optional, greedy, reluctant, static, dynamic, unary, n-ary, ordered service dependencies. Yeah, say that 3 times fast. You know, all of this, all of the ability to specify these things really make the power of dependency interdependencies at the service layer the most powerful aspect that you get out of OSGi. And declarative services does this really well, and we don't want to compromise that functionality. We want to make sure that we give that to developers. We want to do other things, such as integration with configuration admin, like a transparent integration, the same kind of thing that you get in declarative services, right? So that's also a very, very important aspect. And not only just configuration admin, but factory configuration, which is arguably a fairly complex thing to implement when you're trying to do an injection framework. And how does factory configuration, how do you deal with that inside this dependency injection framework, right? It's a fairly complex merger of two worlds. And last but not least, we want to make sure that all of this dependency management is lazy. We don't want to have anything like proxies or service damping that is going to give us timeouts or weird kind of behaviors. We want to make sure that we behave in a very similar fashion to declarative services. When our dependencies are not satisfied, we're passive and lazy and we can wait forever, and the system should continue to run with no issue. So, in the beginning, there was the CDI container. And on the first day, the CDI developed the concept of managed beans, which they spread throughout the CDI container. And a managed bean has this concept of living inside of a scope. Scopes define the life cycle for a set of managed beans inside that scope, right? The life cycle that is defined for this scope, it follows the edges of business logic, right? So, and this results, these leading and trailing edges of the business logic result in several different contexts, which are effectively like object caches floating around in space, that hold the instances of the objects that are wired together. Those wired objects are the dependency injected graph, right? So they live separately inside these scopes. Now, the really cool thing about CDI is that scopes are defined in such a way that it's an abstraction. You can create new scopes. And the set of rules that you apply to these new scopes are arbitrary. They basically are based on your own business logic. So they can even include aspects such as identity. You know, the scope called A. In this case, this is all standard scopes in CDI. And here we have a conversation scope. But the instances of those scopes, the contexts, have a name. And so when you're in your application and you want to operate inside of scope, you have to go to some agent and retrieve the scope. That scope has an identity. So this is a really, really important concept as I keep going through this, that we're going to come back and we're going to borrow. Now, between these different scopes, there is a level of interaction. And the interaction, the ability to interact between these scopes depends on whether a scope is active or not. So, let me illustrate. We have an application scope, which you could imagine kind of behave like singletons in your application. And let's imagine that a request arrives. And so, on the leading edge of the request, an instance of a request scope is created, and that builds a request scope context. And when the application logic accesses one of these request scope objects, the instances are created and they're injected with the object graph. The object graph is created. And so, in order for an object from the request scope to observe the application scope must be active. There must be an active application scope. While the business logic that rules the application scope says, I'm always active. But the session scope might not necessarily be active at that moment because there's no session. And so there's this business rules that control when these different scopes can see each other, or which instance of these scopes can see each other. Now, the injection that happens across these scopes is built on that visibility. And you may find it strange that the arrows here travel in both directions, because the application scope is a long-lived scope. It lives as long as your application. And all of these other scopes have a shorter life cycle. They live and die quickly as the application is being interacted with. And yet, the application scope can see a request scope bean. how does that even work? This is actually the crazy part about CDI that I'm just going to briefly go over, but what happens is a request scope bean is guaranteed to always be proxied whenever it's injected somewhere else. But that definition is just part of its scope business rules, right? So this scope has business rules that say whenever I'm injected somewhere, always put a proxy. This scope, whenever I'm injected somewhere, always put a proxy. This scope, same thing, right? So whenever one of these beans accesses one of these beans, it's getting a proxy. And behind the scenes, the CDI engine is saying, oh, during the thread that my application is accessing this application and it wants this bean, I better have an active session scope from which I can get a bean that's accessible. Otherwise, I'm going to get an exception. So this is really strange because, like, you can even get a conversation from an application, and you know, there could be a million requests happening at once, and yet you're inside your application, and whenever you access that bean, there can only be one, and it could be changing every millisecond. So what the answer is from a CDI guru is simply don't do that. There's no rule that prevents you from doing it. It's merely a suggestion because the business rules already describe how the scope behave, and you're supposed to kind of understand the business rules of that scope. So this is kind of weird, but we'll move on. But keep that in mind. But what we want to do when we kind of tie this into OSGi is we want to be able to access services. That's, you know, it boils down to it. This is the kind of the legacy style part of the application that CDI developers are already kind of familiar with, and yet they still may want to refer to a service here. So how does that happen? Because intrinsically in their application, there's no bean that defines that service. But when they make a reference to a service at a particular injection point, here or here, the CDI extension for OSGi will build a synthetic bean, and that's represented by these blue dots here, which themselves kind of manage the heuristics of how to get those services, the cardinality, the optionality, and all of that stuff. So there's this synthetic bean is basically a mediator to the service registry, and it will fulfill the contract for the injection point by making sure to match the type and the cardinality and all the other qualifiers that might exist on that extension point or on that injection point. All right, that's cool. That means we can have pretty much plain beans and still access services. That's great. From our application scope, or somewhere in our application, we want to provide services. Because these beans, or these scopes, are so short-lived, they're not really adequately designed for the purpose of publishing services into the service registry. So, in our extension, we create a business rule that beans that use our extension can only publish services from application scope beans. So if you have a legacy application and you want to publish a service, you have to do it from an application scope bean. And that's fairly reasonable, I think. Now, furthermore, we really want to integrate with configuration admin. We want to make sure that we can observe configuration and then use that as a dependency. We want to use it for multiple different purposes. For one, we'd like to be able to inject the configuration itself into an injection point somewhere so we can interface with it. We can read the values. And so we have a mechanism to inject into an injection point our configuration. But this is also represented by a synthetic bean that's created at the application scope. This configuration can also be used to alter the state and the rules for our reference beans, our synthetic reference beans. So when you want to specify at configuration time a target filter that would modify the behavior of a particular injection point, a reference injection point, we want to be able to make that happen, right? We want that to be possible. At the same time, we want the configuration to be visible to the bean that's providing a service so that it can provide service properties into the service registry. So that's the full circle. But now we've reached a kind of a crux of a problem, or not necessarily, we have to observe some kind of reality here. All of these requirements are dynamic, and they will affect the entire region of the container that you see. Whenever they are modified based on the definitions of these of these synthetic beans, right? So if they're dynamic, if the references are said to be dynamic or configured to be dynamic, then they would result in a dynamic change. The container would stay alive, but there would be an alteration. A configuration can never be dynamic because it needs to be absorbed into objects directly. So if the configuration changes, or if the references are static, the entire container needs to be taken down and put back up. This is a limitation of the design of the business rules of this part of the application. Okay? So you might think, well, that's pretty limiting. If I have a large application, I don't want it to be going up and down all the time. That could get tedious, it could get expensive. And we realize this. And this is, even though it's close in its ability to consume and provide services and react to configuration, it's not yet very close to what you get in declarative services, because in declarative services you can have multiple components inside your bundle that come alive and active and deactivated on their own life cycle, independent from each other. And so they can interact with each other at the service layer. And this is actually a very powerful thing, and we don't want to lose that. So how do we accomplish this? So, again, going back to the abstractions provided to us in yeah. Yeah.
Is it always one bundle, or is it
always one bundle? Yeah. That's not to mention extensions. Not extensions, just the bundle with beans in it. So we're borrowing again an abstraction that is defined in the CDI specification called pseudoscopes, which we're using as the basis for a new scope called component scoped. And this component scope is this other region. It's a brand new region defined for us to be our playground, to be a peer to a potentially existing application, right? And inside this scope, we can create arbitrary numbers of components that have this behavior, that they're independent from each other, that they're independently configurable, and all of this. They can contain their own isolated graphs of objects, which is important, right? That's one of the major features of CDI, is we want to be able to compose a graph of a dependency injection graph, right? And we also want to make sure that we control the visibility. And actually, we're creating business rules that specify the visibility that would allow us to preserve this behavior, that these can have their own life cycle and won't misbehave, or we won't be able to do something silly and make a mistake. And this is going to enable us to have dynamic component life cycle. And so a component will be able to have a reference. And one thing you might find here is that all of the dependencies that were defined in the application portion of our CDI container all pass through the application scope. However, our components, its dependencies don't pass through the application scope. They actually belong directly to each component. And so they can consume services. They also get synthetic reference beans, and they can publish a service. And they can consume configuration, which can also affect the references and modify, cardinalities and target filters and so on. They can be directly injected, and the configuration is available as service properties if you choose, right? So this is the part of declarative. This is the declarative services that we get. This is the benefit we get from declarative services. The beauty here is that each one of these components has its own isolation layer. But the wonderful thing is that they do have a way of sharing, have a global shared space through the application scope. Because as long as there's an application scope that's alive, the component scopes can survive. So if you want to make your application dynamic without affecting the part of the application that you want to stay alive, that might be the heavier part, and still interact with services, you would do it through the component scope. And these will be able to have their own life cycle, as I mentioned. Okay? So that's a lot of detail, and you're probably thinking, why would I ever do this? Well, it turns out that when you look at it, it's pretty nice. It's slightly more verbose than declarative services, and there's a reason for that. It's because, again, we're following the abstractions and the definitions that are provided to us in the CDI specification. And so, here we have an application scope bean, so we're defining its scope. We have an injection point. We have to use @inject because we don't want to rewrite the injection engine and how it works, and it says that an injection point has to be annotated with @inject. Fine, great. But I want a service here. So I'm going to use a qualifier, which is again a term and a definition created in the CDI spec. But in our case, we're calling it a reference. It's a reference qualifier, and it serves the purpose that we have in declarative services to say, I want a service here at this spot. And we're using a named annotation. And this might seem weird and seem a little bit more verbose. The thing is that CDI also provides a mechanism for controlling unique identification. And so if we use the named annotation, we get naming and unique naming for free. And so by having the named annotation on the reference, we can always refer to this exact reference point and be able to target configuration at any particular reference injection point in order to be able to configure it. And then we get the more standard kind of DS stuff, like we can put a target filter on here. So, and this would look very, very familiar to a CDI developer, and familiar enough to us declarative services developer that we see what is happening and we can tell kind of what is expected here. All right, another one. This is providing a service from a bean. And this is not a component bean. This is just a regular part of our legacy application that we decided we want to attach a service. We want to provide a service into the service registry from. And that's all I need. The service annotation in CDI will decide which type to use to publish in the service registry. So if this type or this class implements interfaces directly, those will be the interfaces used. If there's no direct interfaces, it will use its own type. Or if you specify the type through the properties of the annotation, then you can limit a set to a particular set of types. Okay? And yet, this service is constructed from a potentially arbitrary large object graph. So all the internal wiring of our application, of our service, is hidden. We didn't have to push anything into the service registry with unexported types or anything like that. It's all wired and hidden inside of our application. And this is, you know, arbitrarily deep nesting of injection points here. And the CDI container takes care of all of that for us. Here's a more complex service being published. It's, again, application scope, so it's part of our, you know, the legacy part of our application. I guess what we're calling the application component, actually. I didn't mention it before, but it was written in the title. So this is part of the application, what we're calling the application component. It's a service. It's got two properties. You can see that they form an array. And it's got a service ranking annotation. Well, where the heck did that come from? That actually is a model of a service property type, except it's using CDI qualifiers that the developer himself would have written in this application, and it would follow the rules that the converter has for converting annotations to a string or to a property, right? Which is we already have defined. And so the developer could have developed this, and if we had standard component property types that were accessible at runtime, somewhere else, we could refer to those. But this is a fairly simple workaround. And another difference here is that I still have an injection point, but what I'm injecting here is the configuration. Is the configuration that's available for the application component. And it's being coerced to this config annotation type. This config annotation. And so you get the same kind of type safety, conversion, and the ability to have defaults. This can be reused many places, so it can have defaults on the type, and yet the defaults that are provided on the bean itself will override the defaults that are in the configuration. So we have multiple layers of providing defaults, because multiple beans might be injecting this in different places and may want to specify their own defaults. So that's really, really already very powerful. And we haven't even reached into the component side yet. Here's a really interesting use case that we wanted to make sure that we solved without kind of blowing up on the CDI side or on the OSGi side, right? Here, and this is a very, very common use case in the CDI. What I have here is a producer method. A producer method is kind of like a black box to generate beans. So what this producer method does, it produces beans of type function, which are session scoped. And let's just imagine that the business logic here is that this function has state that I want to share across the session with all of the requests. So I might have a counter here, for instance. So all the session objects, or all the request objects that see the same session should be able to use the same object. But that's kind of hard to do in OSGi, right? Except that by creating this simple producer method, I can specify a reference to a prototype scope service, which is I'm asking for the component property, the component service object, which is a wrapper in CDI to play with the service objects, to get a function, and what I'm going to return is one of the instances of function. So with this simple produces method, I can target specifically the individual scopes that exist inside my application with whatever kind of stateful instance of a service is required in that layer, which had we not provided to CDI, if we had not provided a way to do this, CDI developers would have thrown our implementation away and never looked back, because this is standard stuff. They need to be able to do this, right? So we wanted to make sure that we had a mechanism, an engine that would allow them to do this. And yet we didn't, yeah, okay, so I'll leave it at that, and I'll move on to the next example. This is just a prototype. Of course, this whole thing is a prototype, but this is a prototype for how you might implement an optional service. And the idea is to simply use the optional type. That's debatable whether that's going to be the end result, but we're trying to decide, we're trying to go down a path where we put as little configuration data into the annotations, as few parameters as possible, because that's where CDI developers will also cringe. If there's lots of configuration information in one particular annotation, they would prefer to see multiple annotations that describe, because those can be processed like qualifiers, what CDI expects to use. But this is one way that we could use the type system to actually give us what we are expecting. So this would be, and of course our extension would interpret this and understand what it means. It would say, oh, it's optional, I don't have a service, I can just go up if there's nothing available. Now, we're moving to the other part of the world, which is where we have all of our dynamics accessible to us. And here we have a component bean. And this component bean is requesting, or is depending on, two different PIDs. One is a non-default PID, some arbitrary PID, com.foo, and the default PID, which follows the name of the bean, the generated name of the bean. And so every bean that is a component will have a default configuration associated with it. And so you'll always be able to target the individual components with configuration. And then you'd also have the ability to have more. And here, those configurations, which the ordering here affects the precedent order of which the values in the configurations are accessible or visible. So the values, the properties inside the default PID would, in this case, come last, right? The last man wins, and so those would supersede what comes into the com.foo configuration. And those configurations could affect the reference here, cardinality and target filter. And if this service dependency goes away, or these configurations are modified in such a way, or they're deleted, if these are, it's not clear yet, I'm leaning towards these being both, in this case, optional dependencies. There is a policy property here to be able to say whether a PID is required or optional. And it's still debatable whether they should be required by default or not. So it's debatable. But let's assume for the moment that they are. If the configuration went away, then this component would be destroyed. And yet the rest of the application, if there were one, would still survive. So here's the really interesting part. It took a little bit of mind bending to kind of work out. We have a component which is a factory component. And so, unlike the PID annotation, which is a repeatable annotation, we have a factory PID annotation, which is not, which means that you can only specify one factory PID per component, which is reasonable, because every time a new instance of this factory configuration is created, a new instance of this bean or of this component and its graph will be created. And all of its references, all of its configuration dependencies will be managed independently from other instances. And so they can come and go as they are resolvable. And that's it, but there's a lot more detail. It's also already significant. I think we're moving in a very, very good direction. But a lot of the details are still up in the air. And if you have questions, please feel free to ask.
Your app component annotation, is that declaring a named component in a component scope?
Yes, this is actually a stereotype in CDI definition in terms, which is an annotation which can declare named, which it is, and also have a default scope. And in fact, we're putting business logic in so that when you use component, you can't override the scope. So it always is going to be component scoped.
So how then would you interact? Let's say I want to write JavaEE stuff.
Yep.
Which is often has request scope things.
Mm-hmm.
Can it also be my JavaEE component?
No, you'd be on the other side. If you want to access this stuff, your service has to be on this side.
Right, but so if I'm over there, can I use a component that's on the other side of the fence, or no?
These things are named, so I'm kind of shooting towards yes, but not through traditional access, through what CDI calls dynamic access. So you would have to know more information. You'd have to know, and this is exactly how this works, right? For conversation scope, which is part of the CDI spec, there's an API that says conversation.getA, and then it returns you the object, the root of the object graph for that. It's not directly injected. No, and it can't be because you don't know which one to put there, right? Somebody has to have the intelligence to say, I'm looking specifically for a thing, and here's the API that you use to do that. So here, we might have an API in our extension that says components.get and then the name. And then you could get that thing, and then you could interact with it. People are like, oh my God, I don't know if I can take this anymore. What? Go ahead, Matteo.
Is this one related with CDI, or is it
No.
completely different?
No, it's completely different, and in fact, we deliberately didn't look at CDI because we didn't want to pollute our mind space, right? We're trying really, really hard to solve this problem alongside of this problem, which CDI doesn't do anything for us. It doesn't have a definition for that. And we didn't want to kind of get mired in trying to emulate them in any way. This is purely isolated research. We haven't looked at any other implementation. And this was deliberate. Go ahead.
I'm assuming you have not looked at micro-profile config.
No, not yet. I haven't
I
looked.
think that's probably a better choice, or at least a better starting point. We can influence the future versions that help, but there's already a story for CDI-based configuration injection, which is micro-profile
Right.
config.
Right.
So we should strongly consider using that.
Yeah.
Making yet another way to do things.
Yep.
Okay.
Yep. It's still really new, and we're a year or more into this research. So, anyone else have a question? Or any doubts? Go ahead.
Question about this line between the application scope and the component scope.
Yeah.
Is this in both?
Is this what?
Is this in both directions? From component to application?
So in this direction, on here, no. See the arrow is the visibility. It's only up. I guess the arrow kind of looks backwards, but the visibility is that the component scope can see the application scope.
The other way you look a bit
Yeah.
difficult to achieve.
Yeah. Yeah. So the really nice thing about this model is that you can live completely on this side. You don't need any of this. Your application can be this can be the only style that lives inside your CDI container. You can just have components. You don't need to have an application scope side. And then it looks almost identical to declarative services. And things come up and down. And what might not have been clear and I was trying to emphasize here is that C can be providing a service that is dependency of D, right? And the state of those would affect each other. So if C is not satisfied because it requires a configuration that it doesn't have yet and it doesn't come up, then this configuration isn't satisfied in D because it's a service relationship, and so it's not satisfied either. And all of those types of interactions that you have in declarative services are identical.
And so it might be useful, I think, to represent the scopes possibly in a Venn diagram shape.
Sure.
In terms of the life cycle, because obviously I think all of them live within the life cycle of the application.
I'll have to hire a graphic designer because I suck at this stuff.
Because I think the arrows,
Clearly.
I think the arrows are trying to somehow explain some
Yeah.
relationship and life cycle.
Yeah. Yeah. I agree.
So how is our request scope being able to access a component?
Again, it's the same way that a request scope being accesses a conversation. Exactly this, it would be exactly the same way. There's an API called conversations.getConversation A. That's how a request scope gets a conversation. It needs to know the name, and it needs to call the API associated with that scope.
Right. It's an imperative.
It's an imperative request. It's a dynamic lookup.
Quick statement, the IBM sponsored party has started, so we're officially over, but we can let Ray stay here and carry on.
I mean, yeah. I just have one. I have one question for you guys. Yeah, that actually logging will be injectable anyway. So does this make sense? If anyone doesn't kind of understand or grok this or think that they should and they don't in some aspect, please, I'm really interested in the feedback. We're trying to get this right, and we don't want to leave anybody out or leave any opinions out. We want to make sure we're doing the right thing. So thanks a lot again, but let me know. All right.